So, welcome to this part of the tutorial. It's the third part of the terrain generator, and in this tutorial I would like to discuss another type of a buffer, the so-called index buffer, and in the end I also will introduce you to the set buffer or the depth buffer. It's also called depth buffer. Yeah, what is this thing about? So, as you can remember, the last time at the last tutorial, we kind of ended up over here, having two of these cubes being drawn. It's one cube which we defined with a vertex buffer, and we simply multiplied it with a transition matrix and a translation matrix, and yeah, we drew it then a second time and also let it rotate a little bit differently. So what I would like to point out now as the first is that here we have all of our vertices, and we actually need 36 of such vertices simply for creating one cube. Although a cube actually only has 8 edges, and so theoretically we would need only 8 vertices instead of 36, but we need 36 because we have to draw each triangle, the first triangle of the first side plus the second triangle of the first side, and so on. And there is a better way to do that by simply setting up the 8 corner points of the actual cube and telling the device to use some indices to simply draw the cube a bit. It's much more effectively, and yeah, we actually just need 8 vertices, and for bigger constructs, especially for a whole terrain, simply using the vertex buffer would be a little bit over the top. So the first thing which we're gonna add here will be the index buffer. I call it IB, and we will also need some indices. So next to the vertex array we create also an index array, and the index array just has to be of a integer, or actually a short array is more than enough. So we create here a private static and a read-only short array, and call this indices. Here we're gonna store then our indices. We're gonna do this later. We come back up over here and simply define them soon enough, but first of all, let's add our index buffer. Same as the vertex buffer over here, we actually have to create the index buffer. So IB is new index buffer. Here we have type of short, and our next parameter will be the indices will be our indices, and the third one, no, actually that's the size of the index buffer. So our indices length. So the third parameter will be then the device, and we take our default device. The third then the fourth will be the usage. Here it's enough to have it read-only, usage write-only, so sorry, usage.write-only, and the pool we stick to the default. So yeah, that's the index buffer created, and we also add an event handler. Therefore, let's just do it kind of similar as the vertex buffer one. So I'm gonna copy this and rename it on index buffer create. Everything else stays the same. Actually, here so index buffer is here index buffer, so the sender, we make a copy of the index buffer, and here we simply do the same as we did in the vertex with the vertex buffer down here. We simply set the data, but not of the vertices, but actually of our indices, which is the short array up here, indices. So here we write the actual short array into our index buffer, and the index buffer is actually nothing else but a buffer which stores some numbers. It's nothing special, and the way we're gonna use this is to simply set with the indices how to draw the triangles, how the draw method actually will be. Over here we have the draw primitives, and the draw primitives is simply drawing everything with a vertex buffer. We're gonna change this later a little bit into actually a draw index primitives, so that the device knows that it actually has to look for the indices of the primitives. So yeah, we're index buffer create, we have everything created, simply to the same. So let's go back up here. So the index buffer, when it's created, we're gonna add an event handler, new event handler, and we give him on index buffer create, and additionally on index buffer create we call it, we give it the object. The object is obviously our index buffer, and we have again, similar to the vertex buffer up here, no event arguments. So the next thing which we actually need are our indices. No, first of all, what do we need indices for? First of all, we actually need to change our vertices, because I would like to point out now that the vertices, some of them are very much the same. So we have here from the position, we have here, let's see, -1, -1, 1. This one is the same as that one. Then there should be also a second one which is the same, 1, 1, 1. Yeah, this one is the same as that one. So a little bit down, this game, yeah, it goes on. So we will find some of these values appear down here again, and all of them are just very, very, very often very often to be found. And yeah, we simplify this now. So, and what do we do with the color? We just simply give, yeah, each vertex now a color. And let's go. Let's start with the first one. So the first one we can keep, -1, 1. The second one, -1, -1, 1, we can also keep. It's the second corner, and the third corner will be 1, 1, 1. It's also good. And the fourth corner, it's already, we have it already, so this one we don't need. Then that one is +1, -1, +1. It's a unique one, so we didn't have this yet, so we leave it. And the next one we have already over here, so we can also delete that one. Further than -1, 1, -1, -1, 1, -1, -1, 1, -1 we can keep. It's unique so far. Then plus, plus, minus is also, we didn't have it yet, but this one, minus, 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 we also didn't have. And soon we kind of come to an end, because we actually drew now the first page and the last, and all the other will be then found somewhere over here. 1, 1, minus, this one we had already, 1, 1, -1, 1, 1, -1, so this one we can actually remove. And the last one, 1, -1, -1. And now we have 1, 2, 3, 4, 5, 6, 7, 8. And this should be everything. And all the other numbers down here, we should find somewhere over here in this, in one of these 8 thingies. So all of them are simply duplicates. So you can remove them, and one thing I should have done before, we simply give them now some colors, red, blue, then green, then gold, then what else? Red, blue, green, gold, yellow. No, yellow we had already. Red, blue, green, gold, and no, actually, let's do it like this: gold, green, blue, and red. And that's it. Okay, one more thing we need to change. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So now we have defined all 8 corners of our cube. Therefore, we can reduce now from 36 back to 8. So also the vertex buffer doesn't have to be that big anymore. So we also shorten the vertex buffer. And that's it for the vertex buffer. Did we forget something? No, I don't think so. Okay, the next point will be we need to set now our indices. Now we lost kind of the information of where are the triangles of this. We just have now the corners, but we have no idea where and how to draw the triangles, and this we're gonna do with some indices, with plain numbers. So the indices are, let's define them right over here. The first triangle will be our vertex 0, 1, and 2, and the second triangle will be at 1, 3, and 2. We could paint this on a wall or just draw it on a paper. It would make sense, but it would just take too long. 1, 2, and the second one is 1, 3, 2, new line. The next one will be 4, 5, 6. That's not the back side. And 6, 5, and the 7. So for the front side and for the back side, we kind of used now all numbers at least one. So the 0 corner, the 1 corner, and the 2 forming the first triangle. Then the 1 is similar. The 1 and the 2 is the line where the two triangles are connecting each other. And 3 is then the next unique corner. And then we go totally to the back of the cube and define the other 4 numbers onto our 2 triangles. So this is simply our backside and backside, front side and backside. Front side, backside. Okay, let's do it further. Next value will be, we go now to the sidewards, or let's do the upper side first. It's 0, 5, 4, and the second triangle 0, 2, and 5. So this should be actually our upper side, the upside, and the next one is 1, 6, 7, and 1, 7, 3. So this is now bottom of the cube. And next one, which one is missing? The left and the right one. So the left one should be 0, 6, 1, and 4, 6, 0. And the last one, 2, 3, 7, and 5, 2, 7. So, and this one is the right. We call this not upside, but the top. So that's now our indices, simply plain numbers in a short array, and the short array is now the type of the index, or the indices length is the size of our buffer. And what is the next step? We kind of need to give our device our indices, and we put this somewhere in the Onpaint. Here we go. In the Onpaint, we, after the set stream over here, so we set the stream source with the vertex buffer, and after that we need to also tell the device indices, and the device can then work with it and do all the calculation in the background. So okay, furthermore, I would like to, let's just remove this whole stuff and put it into an own method. We call this method private void Drawbox.
Good then.
And we need now a couple of parameters. The first one will be float the yaw parameter, the float pitch, and the roll, plus the float x, float y, and float c. What we're gonna do over here now, we just simply give these parameters down here, so we can remove it from here. We're gonna bring it down here to have actually a function, a method doing what we want, and angle here your pitch and roll, and our translation matrix will be the x, y, and the c. And so we can simply draw a box as often as we want, and giving it simply some coordinates over here. So what do we have to change as well? We're gonna bring, because this one up here in the setup camera, we already did the same trick. We don't need it over here anymore, so we just remove it because it actually has nothing to do in the setup of the camera. The draw primitives I can remove now as well. Here we're gonna call now the Drawbox. Oh yeah, we need to actually the angle 0.02, and I actually have to define this now. No, angle, we have it. Oh, it's just written wrong. Yeah, it's a float. So now one more thing we need to change over here. We can't just draw the primitives, let this draw primitives would look for all the vertices only, and draw the triangles according to the vertices saved in our vertex buffer. We want to use now both techniques, just the vertices from the vertex buffer plus the information of how to draw them from the index buffer, and therefore we need to call here another function. This function is called index draw indexed primitives. Super. What's his problem? That we need some more different. Okay, we got here now the primitive type, then the base vertex, the min vertex index. So base, the triangle list stays the same. The next thing will be the the base vertex, it stays at 0. The next one will be the minimum vertex index, it's also 0. The next one will be number of vertices, how many vertices do we have? We will reduce them to 8, so there are only 8 vertices. And the next one will be the start index. Yeah, so where to start with the index, also from the first position, so which is 0. And the last one is the prim count, which means the primitives, the number of primitives to render. So how many of the primitives do we have? We can actually set this with the indices. How many indices do we have? We have here 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, so 36. Obviously, the same number as we had previously on our vertices, on our vertex buffer. And if we have 36 indices creating triangles, we draw 12 triangles, which is always a third of our indices, the length, of course. So, okay, so the draw indexed primitives draws now our triangle using the 8 vertices with our indices. Okay, now let's simply call the method here for drawing the box. So the Drawbox, draw box. Here we need now the angle divided by, let's just, whatever, let's write it again, float math pi math.pi, and what is our first box should be at 0, 0, 0, being perfectly in the center. And did we forget anything? Let me think. IndexBuffer create. I have the feeling I forgot something. Let's check it out. Yeah, something is not working. Okay, let's bring first of all the camera a little bit better to our perspective. Therefore, set camera Let's go a bit closer. 004. And what am I doing wrong? No, does it work? Actually, it works, huh? It just looked like it didn't work from the distance. Oh no, here we have an error. Ah, we have an error. We got a problem over here. So, which color? Which color is it? Red, yellow, green seems to be alright. Blue is also alright. Red. Okay. Let's check the indices. 0, 1, 2, 1, 3, 2, 4, 5, 6, 6, 5, 7, 0, 5, 4, 0, 2, 5, 1, 6, 7, 1, 7, 2. No, the 2 is not right, because the 2 we had already over here. So the 3 is missing. Yeah, the 3. How could I mistype this? 3. So 0, 5, 4, 0, 2, 5. Okay, 1, 6, 7, 1, 7, 3. 0, 6, 1, 4, 6, 0, 2, 3, 7, and 5, 2, 7. Yeah, now it should work. Okay, it's a little bit too close. Let's go a little bit further away. Camera, setup camera. Let's go back to 8. And we're gonna like this. Yo. No, we have still a mistake. We have still an error. What the hell? What am I doing wrong? Zero, 1, 2, 1, 3, 2, 4, 5, 6, 6, 5, 7, 4, 0, 2, 5, 3, 0, 6, 1, 4, 6, 0, 2, 3, 7, 5, 2, 7. Everything over here is actually alright. And our vertices minus 1, 1, 1, minus 1, minus 1, 1, 1, 1, 1, and 1, minus 1, 1, minus 1, 1, minus 1, 1, 1, minus 1, and minus, minus, minus. We have 2 times minus, minus, minus. Why do we have 2 times minus, minus, minus? So which one is actually missing? 1, 2, 3, 4 set. 1, 2, 3, 4 minus 1 on this set. So 1, 2, minus, minus. Then here we need a plus still. And here we have 1, minus 1, 1, minus 1, and 1, minus 1, 1, minus, minus. Is this alright now? Yes, so now all are unique. And voila! Now the cube is finally properly rendered. That's it. Yeah, it's quite easy to get a little bit confused with the numbers. Okay, and now what I would like to show is if I create now the Drawbox, simply calling our Drawbox method down here. If we call this now a second time, so it does its thing and it's drawing the primitives. We call this now a second time, but we give it a little bit of a different value. Divided by 2 times 2, 3, and this one divided by 3 multiplied with 2 something. And we're gonna put it a little bit aside. Somewhere minus 0.5 on the x-axis, so it's actually connecting. And here we go. One is rotating much faster than the other one, but what do we see now? The problem is we drew them onto each other, but the one which we drew first is on the background, and the one which we drew secondly, it's on the front side. So if we simply swap these two from the order, it's the other way around. Now the fast spinning one is in the back side and the other one is on the front. So, but actually they should be on the very same level, but we got a little bit of a problem with the depth calculation, with the calculation of the z-axis, and therefore we would need something new, and this is the zBuffer. And the zBuffer is quite an easy thing to implement. It doesn't require much. We simply go to our present parameters, and here we enable the auto depth stencil. So this is true. And the second thing is we actually need the auto set depth stencil format. Here we go. To be depth format dot, and here we have a couple of options, and it doesn't matter. We just take the D16 and now we have nothing. Of course not, because we overwrite it wrongly, because now the zBuffer needs to be cleared as well in our device. Every time when we paint something, we additionally need to clear the zBuffer as well. So clear flags dot zBuffer, and here we go. If we put this actually out over here, it should be then the same speed, and it calculates every little pixel correctly, also in depth. So it doesn't matter in which order we are over here. It's simply swap it and it's still the same result. So yeah, this was a short introduction into the IndexBuffer and the zBuffer, and this is what we need to go a little bit further, and the next tutorial will be the first time that we actually generate a plane terrain. So yeah, see you guys next time. Thank you for watching. And